be here today. So now we're recording, so don't do anything crazy, I guess. All right. If you would like to show yourself, you can, but it's not required. And you can, Zach, yes, that's why we're doing this video today, so that I can help out, so it makes more sense. So, okay, more people are still joining. Okay, I think we get out of here at 11:02 because it's too early schedule. So I'm going to go ahead and share my screen. You guys can see the worksheet. Do you guys know how to do the reactions, like the thumbs up? You can give me like a thumbs up or whatever if you don't want to say any words. That would work too. Okay. Hey, thanks, Levi. Okay, so I don't have the notes up, but I thought we could just go through the questions. And I don't know if it's necessary for me to move the camera, but I want you guys to still be able to hear me. So I'm going to move it. At least it's closer to me, but then maybe you don't really need to look at me because I'm just going to look at the screen for myself. Okay, so this worksheet, I have decided that I will only need you to try to do 15 on each side, okay? So you only need to do 15 on the front side for the naming part, and then only 15 on the back side for the formula writing. I did have like a couple people turn it in already, and they did all of them, so that's awesome. But only 15 on the back. So yeah, there we go. So that'll help cut down the work a little bit. But I do want you to do as many as possible because we are going to be writing these names and formulas for the rest of the year, and so it's very important that we get it done. Okay. Now, a couple other things. We are going to use, like for the naming part, we're just telling like the name of the first ion and the name of the second ion. So this goes back to chapter 7, where like we would have chloride ion. Like for the anions, you know how we changed it to IDE, and for the cations, we used just the name, okay? But the process is we don't use the term ion anymore when it's in the compound, okay? So a couple things, I have the periodic table here. So remember that where we have our stair-step line, that cuts off, and then everything that's on the metal side would be the first part, and then everything on the non-metal side is going to be the second part. So that would be the second word, usually. Okay. But then sometimes when you look at what you're dealing with, I just picked something. Like you see, like in number 1, we have 2 elements. We have Ag and Cl. Okay. But then other times, like number 4, we've got 3 elements. And so I'm not requiring this normally. If it wasn't COVID, I would require you to take a quiz and memorize different things that are called polyatomic ions. Remember we drew the Lewis structures of these. So this sheet is found on the chapter 9 page, and you're going to want to have this list handy. So if you can print this off, you can. If you want to just write it down somewhere, or know where it is so that you can open up the tab, it's important to know that. So like when you see something with multiple letters, instead of using like sulfur and oxygen, you would use the term sulfate, like that, okay? So having this will be very important to helping with the, into there. And so where this stuff is located, if you're on It's Learning, if you go to the chapter 9 page, if you click on that, then on the left side where the paper resources are, there's a folder with the polyatomic ions. So if you click that, the first one, the PI study sheet, is the one that I have open. But then the second one, the polyatomic ions, it also has those, just in different order, I think, or they're already filled in for you or something like that. So that's where you can find those lists, okay? So let's go back to just trying to name things. So when we're naming, the first element, if it's just an element, will have just its name from the periodic table. And then the second element will change to IDE if it's from the periodic table. So AG is silver. And since it comes first, we'll say that its name is silver. In chapter 7, we said like silver ion, but we're not going to do the ion part. We're just saying the silver part. And then the second word of the name will be for the Cl. And since Cl is second, and we said when it's second and it's non-metal, that means that we're going to change it to IDE, just like we did with the anions in chapter 7. So instead of chlorine, we're going to say chloride. So the name of AgCl is silver chloride. Okay? So number 2 is very much like that as well, where we've got Ca and we've got I. For now, don't worry about the 2. That comes from charges. But so for when it's CI, CAI, Ca stands for calcium. And then the I is iodine, but that changes to IDE, so it's iodide. So calcium iodide is the correct answer for number 2. Okay. Does anybody have questions, like just right now, of what I've done? Like, do you have any questions? You can either unmute yourself and try to ask over the microphone. You could type it in the chat. I'm going to see you guys to see if anybody's going to do a thumbs up or anything like that. All right. I should probably move the camera back more. I just don't want to over myself. Yes, Brian, what's your question? So while we're waiting, if you want to go ahead and try another one yourself, you can. And look for ones that have just like 2 elements, like we had 2 elements. Like, so number 3 is going to follow that same process. Okay, yes. So some of them have an ATE ending or an ITE ending because they contain what we call polyatomic ions. So this is linked on the It's Learning Chapter 9 page. If you go to It's Learning Chapter 9 where it says polyatomic ions, if you click right there under paper resources, that's where I found this document. So number 4, so looking at number 4, Mg stands for magnesium. So that's the first part of the name. But then for the second part, we are not going to label sulfur and oxygen second. Like, oh my gosh, Riley, good luck with that. Ugh, scary. So we're not going to label the sulfur and the oxygen separated because the SO4 is on the polyatomic ion list. And polyatomic just means that there's multiple elements together. So SO4 is called sulfate. So instead of calling it sulfur oxygen or sulfur oxide, the correct way to name the SO4 would be to use the term sulfate. That, I'm like pointing, I don't know if you can see, like right there. Okay, so for the answer of MgSO4, magnesium would be the Mg portion, but then sulfate would be the SO4 name. okay? So that's kind of how we use the polyatomic ion list, where when you're looking at the elements listed in the formula, if there's more than 2 elements, then you will need to use one of those names from that list, okay? So another one that I see is like number 10, MgClO4 2. Well, I just picked another magnesium, sorry. But so the first name for magnesium, for the Mg is magnesium, okay? And then the ClO4, it's kind of nice because it's grouped in parentheses, but to name this part, we have to go to that list and look for ClO4. So that is number 15 on the list. The ClO4 is called perchlorate. So for our answer of Mg parentheses ClO4 parentheses 2, it would be magnesium perchlorate. And so the way that you spot that it has one of the names from the study sheet from the polyatomic ions is that, again, it has more than 2 elements in its formula, okay? Now, the last thing that I want to do before moving on to writing the formulas, because we only have a 2-hour delay period today, if you saw on the notes, I don't have the notes open. Oh man, see? Unit 4. There you go. Just open. So on the notes, did we see this list right here? So this list of the ion symbols, when it has more than 1 charge, we use a Roman numeral, okay? So if you ever see copper, or if you ever see iron, or lead, or tin, or nickel, that means that you're going to put a Roman numeral as the name, with its name for the charge, okay? So I'm going to come back to that. It's still on the homework, it's not on this page. Oh, thank you. Now can you see it? I think I did it. Okay, thanks. Sorry. So if you see copper or iron or lead or tin or nickel, all of these elements, they can have more than 1 charge, which is different than like sodium. Sodium always is +1 because it's in the first column, okay? So when you see one of those elements, it needs the ions charge in there as well. So if I go back to, I wonder if I could just say that. That would work. Now can you see the worksheet? Awesome, thanks, Haley. I think I picked the right screen this time. Okay, so like just a little hint, okay? We'll come back to it if we have time. But like number 7 has iron oxide in it. So we need to just make sure that we're doing that one right. And then like number 13, oh wow, nope, don't do that. Number 13 has copper. So those two, 7 and 13, are going to need the parentheses with a Roman numeral, okay? So the way that we figure that out though, we'll see that after we talk about how to write the formula. So now we're going to move to the back side a little bit. So again, if you join late, I have decided that you only have to do 15 on the front and 15 on the back. So instead of doing 40, you only have to do 30 total. Okay, so now the formula writing, we need to use charges. And the whole point is that charges will balance to 0, okay? And sometimes it's nice because if it's like a +1 and a -1, the charges balance each other out. But if they're not +1 - 1 or +2 - 2, then it gets a little bit more confusing, okay? So like for number 31, potassium iodide, I'm going to give you a hint. This is a +1 - 1. So the way that we know this is you would look up what the charge is on potassium from the periodic table. Right here. And remember we wrote down like +1, +2, +3, and then -3, -2, -1. So potassium is a +1 because it's in the +1 column. If you ever see something with just like a plus and not a +1, it still means +1. Okay, I start to do that around now because it's less writing for myself, but you can still write +1. And then the iodide, remember, is iodine. And looking back at the periodic table, iodine is in 7A, which has a -1 charge. So I think I just closed the document. Uh-oh, dang it. 1 second. I was doing so good, guys. Ready? Technology. Okay, so then I have the -1. So again, just the negative without a number after it means -1. So looking at the two charges, like here and here, then if they add together to make 0, then you can just write it as it is. So the answer for this one is KI. Riley, are you asking how to turn it into a PDF, like to write on the PDF? What I opened it with was called DocHub, which I think you guys also have Cami. Yeah, Kaylee, some people use Cami to write on their PDFs, so you could try that too. I don't have Cami on my computer for some reason, but I have DocHub, and that's what I'm using. So if anything, if you can't write on your own computer, you can always just use like a separate piece of paper and write down them and write down the number with it, and that'll count too. Okay. So potassium iodide, the answer is the Ki. Okay, so it's really nice when the charges balance out. Now let's look at, for example, number 33. Because it has potassium, let's just speed up the process, okay? So for 33, potassium permanganate, we know potassium from 31 is K with a +1 charge, okay? But then since permanganate ends in ATE, that tells us that we need to look at our polyatomic ion sheet. So if we look at this one, we're looking for the word permanganate, and that is number 16 on this list. And that is, so that means that we're going to input MnO4 with a -1. And that will be in our formula. So for permanganate, that is MnO4 with a -1 charge. So even though we've got a lot of element symbols now in this whole write-up, it's still a +1 charge with a -1 charge. So that they both cancel. So the correct answer is, she's coming early, KMnO4. Okay, so potassium permanganate is KMnO4, like that. All right, so now let's try one that is not 1 and 1, okay? If it's 2 and 2, it works the same way, just FYI. Like I think number 32 is 2 and 2. But let's look at like number 22. So in the name, nickel 2 is telling us that nickel has a +2 charge. So nickel is Ni, so that means that Ni has a +2 charge. Okay. Sorry, that N looks weird. Okay. Then now we have to look up chloride on the periodic table. So then chlorine is chloride, right? So we're looking for Cl. When we find Cl, then we know that chlorine will have a -1. So even though it's I versus the INE, it's still the same thing. Okay, so then Cl has a -1 charge. Now, this is not the simple NiCl because we have a +2 and -1. Okay, so when you don't have them equal, you have to add more of one of the ions to make it equal. So if we have a +2, that means we need an overall -2 charge. So we would need to have another chlorine, -1, chloride ion. And by doing that, then the two negatives add together to make a -2 charge. So then the final answer for nickel 2 chloride, this is where we use those subscripts to tell how many Cl's we have. So that answer would be NiCl2 for nickel 2 chloride. Okay. There's a shortcut way to do it. And I don't know if today is a good day to show you that, but maybe when we talk about the next section of notes, it might be a good shortcut. Okay. So then, does anybody have any questions about how to do the backside so far? Number 34, ammonium chloride. Ammonium with the IUM, that is actually the only positive polyatomic ion on the whole list. Ammonium is number 2 on this list, NH4 + 1. So the correct answer for ammonium chloride is NH4Cl, because the chlorine has a -1, like we saw in number 22. And if ammonium has a +1 charge, it's just +1 - 1 to cancel out, like that. So you just have to be careful, and we just need to start to get to recognize all of these polyatomic ions when we're doing them. What other questions do you guys have? Number 25 together? Sure. 25, ooh, this one's tricky. So 25 is tin 4 oxide. And remember, just like with the nickel 2 means nickel +2, tin 4 means that SN has a +4 charge. Okay? And then oxide is oxygen. So if we look at the periodic table, we're talking about just O with a negative charge, and so that's going to be the oxygen has a -2. So we have to combine the SN +4 and the O -2, and the charges don't balance. So we would have to double the O -2s, have another one of those, and then that makes an overall negative charge of -4 charge to balance out the +4 charge. So then that answer will be SnO2. Yes, the Roman numeral I can go back. The Roman numeral is the charge and the positive charge for that Roman numeral. So always positive, whatever the number is for the Roman numeral. Did you get that, Jasmine?
Yes, thank you.
You're welcome. Thanks for turning on your microphone. I got a second period person already starting to join, so we're not done the first period. Okay, now this doesn't work with the number 25, but it does work with number 22. So going back to the naming, remember I said that 7 and 13 are going to have a Roman numeral in their name. Okay, so let's go ahead and just do number 7. So Fe stands for iron. And I'm going to put my parentheses because I'm going to have a Roman numeral, but I don't know what it is yet. So I'm just going to leave it for now. And then the O is oxide, which we just saw, because it's oxygen, but it's negative, so it comes second, so it changes to IDE. The trick way to figure out what the charge is for the Roman numeral elements, and if you might get this, or you might watch another video from somebody else, and they might teach you a different way, but if the nickel had a +2 charge, right, there ended up being 2 chlorines. So 90% of the time, 95% of the time, whatever the subscript is on the second ion, that will be the Roman numeral. So like nickel had a Roman numeral of 2, and chlorine, we had 2 of them. So with that in mind, if we look back at the iron and the oxygen, if we have to look to how many of the second ions are there, then that means that the 3 on the outside of the oxygen tells us that iron will have a +3 charge, so its Roman numeral will be a 3. Yes, Bren, on the front side, only 7 and 13 will have Roman numerals in their name. Everything else, we'll just use the names from the periodic table or from the polyatomic ion sheet. Good question. All right, you guys. Well, we do have like 3 minutes left. If you have any more specific questions, you can stay on and ask, or if you want to just try it yourself and then email me if you have questions. I think what will happen, because normally if you're in class, we usually get to check the answer key. So if you miss like a certain number of questions, I think I might resend it back to you to fix it and get a better grade. Okay, so do a 15 on each side, and you only need to do, like, I might send it back for you to try again. Okay. Yes, number 13. It would not be a 2. So for number 13, if Cu is copper, and then O is oxide. Okay. But if we are looking at the outside part, like we did in number 7, to know the charge, there's nothing next to the oxygen on the outside, on the right side. So if there's nothing there, we imply that there's just one of them. So the Roman numeral on number 13 will actually just be 1. So copper 1 oxide is the correct answer for that. All right. And it's not, you don't always have those, but it's tricky when we do. And the reason why we have those is because they're not just in the columns like we have for all of the rest of them. So, yeah. All right, well, I hope you guys have a nice rest of your day. I'm going to start cleaning things up for the next class. So you're welcome to leave if you want. I'm knocking things over again. Or if you have any other last-minute questions, you can ask. Number 9. The correct answer for number 9 is sodium phosphate. I'm trying to type it in. Sodium phosphate for number 9. Na3PO4 sodium phosphate. All right, there's the bell, you guys. I will, we don't have a Zoom call tomorrow, but we'll have another one later on, okay? I'll see you later.